we're going to discuss infinite limits. Okay, so we're going to start with an example. Up till now, the limits we've been looking at were limits where we tried to plug in a number, we either got an answer or we didn't. If we didn't get an answer, then we were able to factor and cancel and reduce and then plug in the number and evaluate the limit and confirm it graphically. All right, let's take a look at this limit. Limit as x goes to 0 of 1 over x. Okay. As with any limit, you should always just try and sub in the number you're approaching first and see what happens. If you do that here, you try and put 0 in, you get 1 over 0, which is undefined. So we know we can't just sub in 0. The next thing you try and do is factor and cancel, but that thing doesn't reduce. So we're kind of in trouble. So we're stuck trying to figure out what happens as x gets close to 0. Now, if we think about how we started limits, we knew if x was getting close to 0, x could be basically two kinds of numbers. Numbers that are on the left of 0 but close to it, or numbers that are on the right of 0. So numbers on the left might be numbers like this, negative 0.1, negative 0.01, or things like that. And then numbers on the right would be things like this, positive 0.1, positive 0.01, and so forth. Okay. So what we're going to have to do, unfortunately, is think about what happens when we sub these numbers in and see if we can make some conclusion about what the limit is. All right, so let's start with these. We'll start with the numbers that are on the right. We'll start from there. Now, we can actually write this with special notation. We can say the limit as x goes to 0 and put a little plus sign after the 0. It looks like an exponent of plus. But that exponent of plus here, which is really not an exponent, it just means from the right. So the way to read this is, what's the limit of 1 over x as x gets close to 0 from the right side of 0? So let's think about that. To do that, I'm going to take these numbers and sub them in. So 1 over 0.1. Or how many times does 0.1 go into 1? We actually know that. That's like 10 times. How many times does 0.01 go into 1? 100 times. And what we start to see is, as we pick numbers that are closer and closer to 0 from the right-hand side, we're getting answers back that are getting bigger and bigger. What we can start to see now is if we did 1 divided by many, many zeros and then a 1, we would get an answer that's really big. It's basically heading towards positive infinity, and that's how we express that. We say that this limit goes to infinity. In other words, we can get those y values to be as big as we want. Okay. Now, we got to go check the numbers from the left next. It turns out there's notation for that also. So we can write the limit as x goes to 0 with a little minus sign as an exponent. And that means we're approaching just from the left side of 0. And the question is, what does that equal? Well, we're going to type in numbers like this. 1 over negative 0.1, which would be negative 10. Or 1 over negative 0.01, which would be negative 100. And 1 over negative 0.00, many, many zeros and a 1, is going to be a number that's negative, right? I don't want to say negative big, but negative with a large absolute value, right? So maybe something like, negative 1 with many, many zeros next to it. Okay? So we think about it, this is heading towards negative infinity. So that's what this limit equals. Okay. So now let's think about this for a second. We were trying to figure out the value of this limit. That's how this story started. And what we decided was we had to look at two other limits. We looked at the limit as x went to 0 from the right only of 1 over x. And then we looked at the limit as x went to 0 from the left only of 1 over x. And in the first case, we got positive infinity. In the second case, we got negative infinity. All right? So here's the answer. The answer to this limit does not exist. And the reason it does not exist is because on the right side of 0, we get positive infinity. On the left side of 0, we get negative infinity. If the limit as x approaches some number from the right does not equal the limit as x approaches some number from the left of a particular function, then we say the two-sided the limit as x goes to a of f of x, does not exist. Go to a new example where maybe the infinite limit might exist. So let's consider the limit as x goes to 2 of 1 over the quantity x minus 2, but squared. Okay? So again, with any of these limits, you need to realize, well, you should try and plug in the number first. We plug in the number first. 2 minus 2 is 0. 0 squared is 0. So that's not going to work. Okay? Additionally, if you try and simplify this, you can't. So we have to resort to considering two limits. The limit as x goes to 2 from the left of 1 over x minus 2 squared. And then this other limit, the limit as x goes to 2 from the right of 1 over x minus 2 squared. Okay, so you can start to see, it might be tough to start to calculate these things, at least in our head. So for example, let's consider numbers that are left of 2. So it might be a number like 1.9 or 1.99 and so forth. Well, if I plug one of these numbers in, I get 1 over 1.9 minus 2 squared. Now, I can do 1.9 minus 2 in my head, but I don't know that it really matters. It's negative 0.1, and I'm going to square that. And if I square that, I actually get positive 0.01. So I'm getting 1 over 0.01, or 100. So I could keep doing this, but I think I could skip the rest of it if I just do a little bit of thinking. If I put in a number like 1.99 now, and I put that in here, then 1.99 minus 2 would be an even smaller decimal. It would be like negative, or I shouldn't say smaller, but closer to 0. It would be like negative 0.01. And then when I square it, it becomes positive and it's smaller, like negative point, you have 3 zeros and a 1. So if I could proceed in this fashion, this fashion, what I'm going to notice is that I keep getting a smaller and smaller positive denominator. So in a sense, what this turns out to be is 1 divided by an extremely small, let's not say small, let's say this. It's 1 divided by a positive number that is close to 0. So if I take a 1 or any number, fixed number, and I divide it by a positive number that's really close to 0, I should get back a very big answer, basically infinity. So this limit's infinity. Okay? So there's some fuzzy math for you. 1 divided by a number close to 0 is basically really huge. It goes to infinity. So this one here, same reasoning. There's some symmetry here, because if I type in 2.1 for x, 2.1 minus 2 squared is the same thing as doing 1.9 minus 2 squared. And that's the beauty of the squared. The squared takes the negatives and makes them go away, right? You can have a negative times a negative, which is positive. Over here, a positive times a positive, positive. So this is 1 over 0.01, or 100. So this limit's also going to infinity. Well, since they're both going to infinity, we can say the original limit equals infinity. Consider some other problems. So let's consider this. What's the limit as x goes to 3 from the right of negative 5 over x minus 3? What's the limit as x goes to 3 from the left of negative 5 over x minus 3? And then finally, what can we say about this limit as x goes to 3 of negative 5 over x minus 3? Let me just fix this a little bit here. Should say negative 5. Let's give these three a try and see what we can. So for this first one, if we plug in a number like 3.1 into here, 3.1 minus 3 is going to be very small, or I should say a positive number that's close to 0. So we have negative 5 divided by some positive number that's close to 0. Well, that's going to give us negative infinity, right? Because you're going to take negative 5 and break it into many, many, many parts. Here on this one, we plug in a number like 2.9. Now we have 2.9 minus 3. That's a negative number that's close to 0. You can kind of see why that I say close to 0, because if I said a negative small number, that might mean like negative 1,000,000, actually, right? Smaller numbers are to the left on the number lines, and you'd say close to 0 here. Negative number that's close to 0 might be like negative 0.001. If I divide that into negative 5, I'm going to get a positive answer, and it's going to be very big. And then lastly, that tells us this limit here at the bottom, which doesn't say left or right, which means it's a two-sided limit, doesn't exist. Okay, let's try one more problem. So how about this one? The limit as x goes to 3 again, from the left, of x over x plus 3. The limit as x goes to 3 from the right of x over x plus 3. And then lastly, we'll call this the two-sided limit. The limit as x goes to 3 from both sides of x over x plus. Actually, you know what? I should be careful here. This should be x goes to negative 3, x goes to negative 3, x goes to negative 3 from the left, right, and then both sides. Sometimes I get a little nervous with the x on the top, but if you think about it, what this means is we're getting a number very close to negative 3 on the top. In essence, the top is just like having the number negative 3 up there. Okay? And on the bottom, we plug in a number that's close to negative 3 but left of it, like negative 3.01. Right? So that's what would be on the top. On the bottom, I'm really getting negative 0.01 when I add these things. Right? And if we divide that, I'm going to get a positive number that's actually very big. So this answer is infinity. So this next one, same reasoning. If I type in a number that's right of negative 3, so maybe like negative 2.999, that's to the right of it. And on the top, I basically have negative 3. And on the bottom, I have a positive 0.001. When I divide those, I'm going to get a negative answer. And 0.001 goes into 2.99999 many times. So negative infinity. And then lastly, this thing doesn't exist because the limit from the left and the limit from the right are not equal.